MDI for today. So remember we've talked about 3 different kinds of angles. We've talked about central angles, we've talked about inscribed angles, and we've talked about inside secant angles. Oops. Inside secant angles. So what we're trying to do is we're trying to figure out the measure of x, which is down here, the measure of y, which is right here, and the measure of z, which is right here. So in order to figure out what x is, if we look at where the vertex of x is, we can see that it's on the circle, which means that it is an inscribed circle. So if we follow this out, we follow the sides out to where it touches the circle, we can see that this is the arc that goes along with that inscribed circle, or with that inscribed angle. And we know that an inscribed angle is half the distance, or half the measure of its arc. So we just take 54 divided by 2, so x is 27 degrees. For y, if we look here, we can see that the vertex for y is actually at the center of the circle. So that is a central angle. And again, if we do the same thing, follow these out, we can see that the arc that we need to find that angle is this one right here. And we know that a central angle is the same measure as its intercepted arc. So if the arc is 47 degrees, then that means that the angle itself is also 47 degrees. Z is probably the most difficult one. So Z is made up of these 2 secants right here. So it is an inside secant. Its vertex is not at the center, so it's not a central angle, and its vertex is not on the circle, so it has to be an inside secant. So remember we talked yesterday about finding the angle in its vertical angle, and then using those 2 intercepted arcs to figure out what the measure of that angle is. So remember, for the measure of the angle, we're taking half of arc 1 plus arc 2, or A plus B. So whatever is inside here, these have to be arcs. So we can see one of them is 46, one of them is this 54 up here. So we add those together, which is 100. So if we take half of 100, we can see that Z is equal to 50 degrees. All right, this is our second day on secants and tangents. Same success criteria as yesterday. First thing is just a quick refresher on an inside secant. Okay, so if the lines cross inside, it kind of looks like you've got a plus symbol here. So if the intersection is inside the circle, then we're going to add these 2 arcs together and divide by 2 to figure out what these 2 angles are equal to. And remember, this angle here is congruent to this angle here. So if you find one of those angles, you found its vertical angle as well. This is for an outside secant. So if you notice, each one of these angles, the vertex is outside the circle. Okay? They all 3 use the same formula, but they all have different characteristics. So in this first one, these are 2 secants that form the angle. So secant line here, secant line here. This one is 1 tangent and 1 secant. So secant here, tangent here. And on this one, you have 2 tangents. So it doesn't matter how your outside secant angle is created. It doesn't matter whether you have 2 secants, 2 tangents, or 1 tangent and 1 secant. They all are going to be 1/2 times the difference between the outside and the inside arc. So it's always the bigger one minus the small. And if you notice, the small one is always closer to the angle. So the small one is always the inside. So you could also think of it as outside and inside. Okay? Whatever goes in here, these have to be measures of arcs. Okay, you cannot put the measure of an angle in here. This is where your angle goes. Okay, so we're going to do a few examples. Probably the best thing to do is to look at what it is you're trying to figure out. So in this one, it's asking us, what is the measure of angle APD? And just like we talked about again yesterday, remember that the middle letter is the vertex of your angle. So if you can find that letter, we can see that this part right here, that angle is what we want to know. It also tells us that the measure of arc AD is 133, so that's this arc right here. And it also tells us that the measure of arc BC, this one right here, is 48 degrees. So because the angle, the vertex of the angle is outside the circle, we have an outside secant. So we're going to do measure of angle 1 is equal to half the difference between arc A and arc B. So if we kind of work our way from outside the arc to the angle, we can kind of put everything into the place where it belongs. So if we start with 133, we can see that 133 is an arc, so it's going to go somewhere in here. And we can see that it's the bigger of the two arcs. So this is going to be 133. We can see that 48 is another arc. And so since there's only another place for arcs to go, we're going to put that where B is. And then what we're trying to figure out is the measure of angle 1, which is where the question mark is. So if we want to, we can just put like X over here, or we can just leave it as the measure of angle 1. It doesn't really matter. So first thing that we want to do, think about your order of operations. So do what's inside the parentheses first. So X is equal to 1/2. 133 minus 48, I believe, is 85. Should put degrees on all of these. So then we just have to take half of 85. So X would be equal to 42.5 degrees. All right. I am going to change this just a little bit. So I'm just going to do a couple at a time so we don't get so overwhelmed. All right, if we look at the first one, if we see where this angle is, the vertex of that angle is inside the circle. So this is an inside secant angle. Okay? And if it's inside, remember where those two cross makes it look like a plus sign. So when we do that formula, we're doing A plus B instead of A minus B. Inside is add, outside is subtract. So again, to do this, all we're going to do is, this is the angle that we want to know. So we find its vertical angle, and we use those two intercepted arcs for the arcs that go inside here. So again, these have to be arcs in here. This has to be the angle. So our angle X is equal to 1/2 of the big arc plus the little arc, or vice versa. You can do it either way. Again, do what's inside your parentheses first. So 90 plus 46 is 136. You're going to take half of that, and so X is equal to 68 degrees. On B, we notice that we have our vertex is outside of the circle, which means that this is an outside secant. And when we do outside secants, remember we use the same formula, we just change the plus into a minus. So we do measure of angle 1 is equal to half A minus B. And again, A and B are both arcs. The measure of angle 1 has to be where an angle is. So if we start on the outside and work our way towards the angle, that might help us out. So we can see that 95 is an arc, and it's the bigger arc, so we're going to put that one in for A. So half 95 minus, okay, the next one that we come to is Z. Z is also an arc, and it's the smaller one, so we're going to put that one in for B. And then we come to 20. 20 is where the angle is, so we're going to put that one in over here. So that's 20. All right, if you cut something in half, the way to undo cutting something in half or dividing by 2 would be to multiply by 2. So in order to get z by itself, the first thing we want to do is get rid of this fraction here. So we're going to multiply both sides by 2. So that's going to get rid of the fraction, and we're just going to bring the 95 minus z down. 2 times 20 is 40. And then from here, there's a few different strategies that you can use, but I think the one that's going to be most helpful is just to subtract 95. When you bring this down, make sure that you bring the negative sign with the z. Since these are both negative, you want to divide both sides by -1. So that's going to take away the negatives. So z is equal to 55 degrees. All right, on these last two, both of these are also outside secants. So we're going to set up our formula again, 1/2 a minus b. Again, start with the outside and work your way towards the angle. So w we can see is an arc, and it's the bigger because it's the outside. So we're going to put that where a is. 110 is the other arc, it's the small one, so we're going to put that where B is. And then 70 is the angle. So just like the last one that we did, we want to get rid of this fraction first because we have to get at W by itself. So multiply by 2 on both sides. That gets rid of our fraction here. 2 times 70 is 140. W minus 110. To get W by itself, all we have to do is add 110. So W is equal to 250 degrees. Last one. Again, outside secant, so we're still going to use that measure of angle 1 is equal to 1/2 a minus b, sorry. Again, start with the outside one, work your way towards the angle. 110 is the outside arc, it's going to go in for A. 30 is the inside arc, it's going to go for B. And Y is the angle that we're trying to figure out, so that's going to go over here. Since all of the numbers are over here, all we have to do is think about our order of operations. So we're going to do what's inside the parentheses first. And then we're going to find what 1/2 of 80 is, which is 40 degrees. So we know that Y is equal to 40 degrees.